belt and pulley calculations. I'm going to read you a problem, and then I will work through it for you. In a pulley system, pulley A is moving at 3,000 revolutions per minute and has a diameter of 20 inches. Three pulleys, B, C, and D, all of different sizes, are attached to a single output axle. Speed and torque output are changed within the system by moving the drive belt between pulleys B, C, and D. So let's figure out how to draw this. We have pulley A, and pulley A, it says, is 20 inches in diameter. And it says that it is moving at a rate, its angular velocity, (3,000 RPM). That's pretty quick. This is attached to three pulleys of different sizes attached to a single output axle. So let's just make some assumptions here. B is on the outside, and then C, and then D. No idea what size these are in relationship to A because it doesn't tell us. Here's the belt that goes around those. So that is all the information that we're given. Question A. A speed of 4,000 RPM is required when the dry belt is connected to pulley B. What is the diameter of pulley B? So it says, it's saying that the angular velocity at B needs to be 4,000 RPM. So it's saying find, it says what's the diameter of pulley B? Find the diameter at B. Those are the information that's given and the question in symbols. So using our belt and pulley ratio, we know that the angular velocity of the in divided by the angular velocity of the out should be equal to the diameter of the out divided by the diameter of the in. In this problem, we know that the angular velocity of the in, which is what A is in this case, is 3,000. Angular velocity of the out, we were just told in this problem, is 4,000. And that is equal to the diameter of the out, we don't know what that is, that's the diameter of B, divided by the diameter of the in, which is 20 inches. Doing some simplifying here, we can cancel RPMs. We can divide the top and bottom by 1,000 and we get 3/4. So getting the diameter of B by itself, multiply both sides by 20, and you get 20 times 3/4, this is in inches now, equals the diameter at B. 4 goes into 20 5 times. 5 times 3 is 15. The diameter of B is 15 inches. Let me add that up here. And now let's erase A and let's go to the next question. The next question is, it's really the same question. Same question in concept. A speed of 5,000 RPM is required when the dry belt is connected to pulley C. So it's saying, given the angular velocity at C is 5,000 RPM. Find, it says, what is the diameter of pulley C? to find the diameter at pulley C. So we do this the same way. The angular velocity of the in divided by the angular velocity of the out is going to equal the diameter of the out divided by the diameter of the in. In this case, the angular velocity of the in is 3,000. Angular velocity of the output is at C, is 5,000. The diameter of the out, that's the diameter at C, we don't know what that is, divided by the diameter of the in, which is 20 inches once again. Doing some canceling here, we can divide 1,000 from the top and the bottom. We can divide revolutions per minute, top and the bottom. To get the diameter by itself, multiply both sides by 20. So you get 20 inches times 3/5 equals the diameter at C. One little canceling. 20 divided by 5 is 4. 4 times 3 is 12. So we get 12 inches is the diameter at C. Write that down up here. So I can erase this to do the next question. The next question is very similar in nature. A speed of 7,000 RPM is required to drive when the drive belt is connected to pulley D. So pulley D, we need 7,000 RPM. And it says, what is the diameter of pulley D? So find the diameter of pulley D. So it's the same concept again. Angular velocity of in divided by angular velocity of out is going to equal the diameter of the out divided by diameter of in. We've done this enough to know. We only have to do it once to know. Angular velocity of in over out we've found to be 3/5. That's what it reduces to. I'm sorry, that's not true. It's a different angular velocity here. The in is 3,000. The out is 7,000. Diameter of the out, that's at D, we don't know. Diameter of the in, that's 20 inches, we do know. Once again, the 1,000 revolutions per minute cancel. So we're left with multiplying both sides by 20. We get 20 inch times 3/7 equals the diameter of D. Nothing cancels here. 20 times 3 is 60. 60 divided by 7 is approximately 8.57. So that means the diameter of C is 8.57 inches. Pardon me, not C, the D. Diameter of D.